Yeah, waste to energy. It's a pleasure for me to speak about waste to energy. The first thing I want to talk about is the waste hierarchy. Where is waste to energy in the context of the waste hierarchy? So waste combustion, waste recovery, or waste recovery, a waste to energy plant is considered to be a recovery facility if the R1 factor is higher than 0.65. This R1 factor is a theoretical factor which gives an indication of the efficiency of the plant. So for electrical production only, the efficiency of the plant must be above 20%. That means from a thermal capacity of about 100 megawatt, we can produce about 20 to 23 megawatt of electrical energy. So what happens with the waste in Europe? So in average in the European Union, we have a recycling rate of about 44%, and about 27 to 28% of waste goes to the waste incineration and to landfill. What we can see here for the countries like Germany, Belgium, and Sweden, we have a recycling rate of about between 50 and 64%, and the incineration rate is between 35 and 50%. In countries with a weaker economy, like Greece here, there is no waste incineration and a very low recycling rate, and about 80% goes to landfill. So how does it look like in Europe? So Germany and France have about 100 waste to energy plants, and even small Switzerland with about 8.2 million, a population of 8.2 million, has about 30 waste to energy plants. So, and that's the reason from our perspective that waste to energy is not competing with recycling, but with landfilling, because all materials, if they are recycled, usually they are downgraded, down-recycled, and will eventually reach the end of their useful lifetime. And from our perspective, the best way to deal with this residual waste from the recycling is to incinerate it and not to landfill. Regarding landfill, it's recognized that it's not a long-term viable solution because of the emission of greenhouse gases, mainly methane, and the leaching into soil and groundwater. Therefore, waste to energy for mixed MSW and anaerobic digestion for source separated organic waste is attracting great interest worldwide. So how does a waste to energy plant look like? From left to right, we have here the tipping area with a bulky waste crusher, or if necessary, then we have here the waste bunker with the waste crane. The waste will be mixed in this bunker, brought to the feed hopper, goes down the feed chute, and here will be incinerated in the combustion chamber. The flue gas goes through the boiler. The energy of the flue gas is reduced on the way through the boiler. Steam is produced, and here we have the flue gas treatment, and at the end the flue gas is released to the atmosphere through the stack. The energy production takes place here in a turbine generator set, and if possible there can be a steam offtake or offtake for district heating. Here a section through the grate. Here the waste comes down by gravity and static pressure, goes to the grate into the combustion chamber, and the fuel agitation takes place through these great bars, which gives a very good combustion result with a very low remaining carbon in the bottom ash. So the flexibility of the grate system is remarkable. The grate incineration systems are used all around the world. You can say we have a very low calorific value in China. Starts with about 5,000 to 6,000 up to 8,000 kilojoule per kilogram. In Switzerland, for example, we have about 13,000. In some plants in Europe, we have a calorific value up to 15,000 kilojoule per kilogram. RDF, we spoke, or Gas spoke about RDF. RDF is in a range, let's say, between 14,000 and 18,000 kilojoule per kilogram, and could be incinerated on a grate system as well. The combustion technologies in Europe, which technologies have been awarded for a project in the last 10 years, between 2005 and 2014. The blue columns are projects with grate incineration, and the dark green columns are fluidized bed projects, and the very light green columns are showing the projects with gasification pyrolysis. So what are the benefits of waste to energy? There are more than 90% of the energy contained in the waste can be recovered if there is a combination between district heating, for example, and electricity production. The waste-to-energy plant supplies electricity, can be connected to district heating, district cooling, or supply heat in the form of steam directly to an industrial process, like a paper mill, for example. The efficiency of the plants can be even optimized. Here we have a plant in Brescia with a net electrical output or net electrical efficiency of about 25%. We have the throughput through this plant, those are 3 lines, is about 750,000 tons per year, and the energy produced is about 70 megawatt. The highest efficiency we have in the Amsterdam plant. People call it the waste-fired power plant because the net electrical efficiency goes up to, or is between 30 and 32%. Remarkably, here are the high steam, are the high steam parameters with about 130 bar and 440 degrees. Further benefits of waste to energy, so the solid residues can be reused. I mean, I know the discussions here in Australia, but in Europe, the bottom ash is usually used for road base, for foundation construction, etc. And another advantage is that the ferrous and non-ferrous metals can be easily extracted. We can see some pictures here. On the right side, this is a mixture between, or alloy between aluminium, copper, can be easily extracted with an eddy current extractor, and ferrous metals can be easily extracted by a magnetic separator. Waste to energy, or the waste to energy plants introduced by us, are all designed according to European standards. Therefore, the emissions are typically very low and well below the emission limits. Another advantage is that there's a pollution sink, you can say, that materials like heavy metals, for example, will be taken out of the recycling circle. and will go to a secure landfill. Dry flue gas cleaning systems are available to minimize the water usage, especially in Australia. I think this is an issue to reduce the consumption of water as much as possible. Waste to energy is clean, proven, and it will be continuously observed. The measurements at the stack will have a direct connection to the authorities. It will be constantly checked if the emissions are within the standards. Usually there are publicly available or accessible websites where everybody can watch the situation at the plant or which pollutants are generated. Usually in the beginning, when such a plant starts up, there is a lot of traffic on this website, and it goes away after a time. So we have in Europe the Industrial Emission Directive, which is the most stringent, which gives us, the waste to energy plants, the most stringent emission limits of any industry, and it's only with the best available technology those emission limits can be reached. The result of that is that the waste to energy plants, or the emissions of the waste to energy plants, are negligible compared to other sources. And even our environmental minister, or the former environmental minister, Jürgen Trittin, member of the Green Party, said that dioxin emissions from waste to energy are not an issue. In fact, in 1990, the amount of dioxin compared to the total amount of dioxin which has been released in Germany was about 1/3. In 2000, it was less than 1%. So here we have some values from an actual plant. On the right column, you can see the values from the permit. Oops. Here with CO, dust, NOx, SO2, HCl dioxin, and you can see that the actual values measured over time are just a fraction of that. And that's the reason why in Europe plants are built in the middle of the city. You can say the black arrows are showing the Louvre, Eiffel Tower, and in the proximity of those tourist attractions, there are 3 plants with significant capacities. Another example is a plant in Bern. The old plant was even closer to the city. They had to extend, they had to increase the capacity, and you can see the proximity to the central station. There's a picture showing from behind the plant in the direction of the central station, and here again you can see how close residential areas and industrial areas are. And waste to energy can be an architectural statement as well. This is a plant in Roskilde, Denmark. It's designed like a cathedral. Synergies between waste to energy and anaerobic digestion, I just want to mention that as well. If anaerobic digestion for source-separated organic waste and the waste to energy plant is built on one site, it gives a higher efficiency because a lot of the infrastructure can be used by both, and the low-grade heat can be used in the anaerobic digestion, and the wastewater from anaerobic digestion can be used again in the waste to energy plant. So, adaptability and cornerstones of a waste to energy project. So we are sure that the great technology we offer is suitable to the Australian market. It's a proven technology with decades of track records, proven track records. What is important for the project is early public engagement and education. And I think there are a lot of good examples in Europe where the people can learn from and help to overcome their reluctance. The timeline for design and construction, including commissioning of a plant, is about 36 months, plus the time for works, planning, EPA approval, etc. From what we learned until now, that will take about, or at least in Western Australia, it would be around 18 months to be considered. What is important for a project as well is a secure waste stream, which has to be in place for about 20 to 25 years. So the summary of that, the net electrical output of waste-to-energy plant is about 550 or between 550 to 900 tons. For the Australian market, we guess we would be somewhere between 650 and 700 kilowatt hours per ton. The electrical efficiency might be above 20 or between 20 and 24%. The combined efficiency, if we have a offtake for steam, can reach above 90%. The waste-to-energy plant can be located wherever it's necessary. We have seen that they are sometimes practically in the middle of the city, can as well be built close to a big energy off-taker. The energy from waste plants, or the energy from waste-to-energy plants, is to a large scale CO2 neutral because of the high amount of renewables we have inside the waste. Bottom ash is usually somewhere, or the amount of bottom ash in the incineration process is about 20 to 25% by weight. Minerals can be reused for construction purposes. Metals can be recovered as well. The fly ash, and this is are the residues which are really need to be landfilled. This is amount of 3 to 4% of the incoming waste. So that means that the diversion from landfill is about 95, 96%. Yeah, the waste-to-energy technology, which is grade-based, is well proven, reliable, has availability usually about more than 90%, 92%. So it runs usually 8,000 hours, and after 8,000 hours the plant is stopped and we do a revision, and this is the case for a lifespan of 25, 30 years. There are even older plants around. The emission regulations are the most stringent of every industry, which is important for public consultations, so there is no harm from waste-to-energy plants. And as well, very important is that waste-to-energy doesn't compete with material recycling, because all recycled materials will sooner or later, they will reach their end of life. And last but not least, there are many synergies if waste-to-energy and anaerobic digestion would be combined at one site. So that's the end of my presentation. Happy to answer questions if you have.
Are there directives in Europe that require the waste to go through recycling facilities before it's burnt, or all of these mass burn?
It is, I mean, there are regulations, and but it's not required to go through a recycling process. So, I mean, we are flexible in case of, or regarding the incoming waste, so it must not be sorted. Regarding the sizes, we can receive waste size is about 800 by 500 by 800, something like that. Yeah, and that goes down to RDF, which is quite small.
Ron Wainberg, MRA Consulting. Those facilities in Paris and Vienna,
Yeah.
in Copenhagen and so forth, what sort of gate fee do they charge for the waste? And is there a state subsidy of some sort for the processing of the waste through those facilities? In other words, what does local government have to pay to get the waste processed there?
So I'm not sure. I can't. I know in Germany it was a time where they had a very low gate fee, which was about $75, something like that, when there was not much waste around. But then it went up to, let's say, $150 or even above. So I can't answer the question for this plants in Paris.
Typically, the gate fee in Germany.
Yeah, I would say it's somewhere around $150 to $200, I would say. But as I said, we are usually in charge for the construction of the plant, and for the operation we usually have partners. So in these commercial issues, we are as Martin GmbH or Martin Biopower, we are not involved. Okay. Thank you very much.